So, welcome everybody. What I'm presenting to you is the result of a European research project which is called urbanAPI. And this time API stands for Agile Policy Implementation. And this just means the policy isn't fixed. You can influence it on several levels. And within this project, we are searching for tools which support urban planning, decision support, and even communication to the public, and at the final level, also public participation. In all, 3 tools were developed. One of them is a 3D virtual reality application, so they call it. Another one is dealing with social economic dissemination, how the city might grow in the future or even decline. And the third one is an application which tracks mobile device data. So whenever you're looking with your cell phone, this generates a lot of data. And you can explore this data and find trajectories and different paths of people. And this is done by some colleagues from the Austrian Institute of Technology. And they have some very interesting results, but this is another tool which I'm going to show today. My topic today is 3D VR. We have several partners in this project, especially the city partners are important. They provide us the ideas and requirements for the applications. And finally, they provide data which we can test. And they are also interested in the results, of course, and they will test drive the applications for us and give us important feedback. And we have already concluded the first analysis session with them, and the final analysis session is to be planned in November this year. So what are the main topics for cities like Bologna in Italy? It has a very, very nice historic city center which cannot be changed that easily. And they also encountered that people live there. So people don't live in a museum, they have some requirements for infrastructure, parking, waste management, and all this. And if you want to change something within the historic campus, as you can see, there's a lot of space used in the city for parking or even for waste management, which is totally different. And I knew it, they use public garbage bins. So these garbage bins are located all over the city, and you just go there, put this stuff there. So this is very important to know where these bins are. And if you change something within this, you have to involve the citizens to get some feedback, or they will complain afterwards, and it's a lot of trouble. So, how has city planning been done in the past? Physical models, very expensive, and you can see probably under the glass, and you can really interact with this. Also, the feedback options are very limited, and you need to have some expert there to talk to, even to understand the issues. And on a formal basis, there's a so-called policy cycle, which says how to do urban planning. So the first stage, they start with a survey, they get data, this is input for the next analysis phase, which you can see as what is needed for the future. Then they start the planning, and after the plans, decisions are made, typically from politicians. After the decisions are made, the plan is implemented, and finally evaluated and reviewed, and should give some input for the next phase. So this is a typical top-down approach for planning. And if you involve citizens, for example, you can involve them in the planning phase important after the planning phase, give you early feedback if this is really what is desired of citizens. And even you can involve them early to survey phase, ask them what do you need, or is there anything which you don't want in your city. So for these particular points in the policy cycle, we can support it with tools, with several tools. For example, a 3D application that shows what is planned, or even give some kind of form or mailing list, such things to communicate with the public. Now we created some prototype models, and we used X-Video as a 3D component, Liferay as a platform, because it's already offering a lot of ready-to-use components. For example, blogs and web content displays, so you can use it right out of the box, and it also offers very sophisticated user management system, so we can give these accounts to citizens, they can do things on their own. And additionally, a lot of JavaScript libraries for JS, JP, OpenAPI, and we also created a backend service for the user data, the stored in the database. And all the data we get from the cities has been prepared with our city server 3D application. As you might have learned yesterday, the cities are using 3D as a storage format, as CityGML is the web of choice for that. So we are already prepared data. Now, switch to the demo. So this is the Liferay application with scenario setup. We have architectural comparison, for example. We have two designs, A and B, which are to be compared. And within this 3D component, you can navigate freely, fly around the helicopter mode, and get an overview about it. And with our component, we have the same things. And if you move around here, you can see that the 2D map is always kept the same. So you can also click in the 2D map and it syncs back to the 3D displays. And one important thing is that you have the option to have some function. Very interesting, for example, this slide here with the two buildings. You can directly move to several positions and compare them in different views. So it's obvious here that there's a huge difference between them. And finally, people can give some feedback by voting from the social media parts from Liferay. You can vote for A or B. So this is just one scenario. I'm showing a different scenario. I use the same components in a little different setup. For example, I can ask people to provide their own view of the city. For example, they can place objects within the scene, and they can even upload own designs. Here's down below on the left side, you can see a special component which called upload a zip archive with some text to do so. I did that before. Just click on it and then build it. Now I can just click on the scene and you see this has been placed where it's clicking. And now you can select it and change whatever I want. For example, I can clean it up, rotate it, or move it somewhere else. This is all done with very new single and plane sensors from Xfilm, which is very cool because we were already working on similar stuff and then came out with these facilities, and it's perfect for us. You can even scale the object, make it smaller or larger, but this is a very dangerous function. I had some discussion with an architect from Vienna. They had a competition for the huge sports arena. It wasn't fitting there, and he just took an old design from another sports arena, scaled it down to fit it. And then they discovered, okay, there's a ramp for cars, but the ramp is just 1 meter now. So we can't get in. Okay, now we're in trouble. So this is a very questionable function, so we just put it in the buttons because they requested it. Oh, let's see if this is really useful. So there's another thing here. If you put it to the public, you can even move objects, and your own positions are marked with these red cones. So if you give it to the public, people are moving the object somewhere, can always track down where they've been before. And there's another option here. You can just click on the scene here and put some annotation. Just click on it again and you can change it or even delete it. And this annotation has been put to the list of annotations here. So whenever you move somewhere and then click back on the annotation, it's going back to the point where you have been when you made the annotation. So based on this, you have also the possibility to have a tabular view of all the annotations. This is what the planning department normally uses, just to get an overview. This is just an example of all the possibilities you have with this tool. And just one final thing. With these architectural components, conditions, you always have some requirement to do some shadow analysis. And in Vienna, which is providing the data for this showcase, they have a special department which is only responsible for doing shadow analysis, and it takes about 2 weeks for one building because we have a very complicated 2-hour shape policy. So we also integrated some basic shadowing analysis here. We're just moving the component up. It's easier. And with this component you can set the time of day, the date of course. That's night in Vienna. You can see how the shadow is cast in different buildings. And this is just a function out of the box from Xfilm, which is really cool, I would say. Doing this shadow simulation, you can even animate this. And we had a student which was doing some paper on this, just to calculate the trajectory of the sun based on several other papers, and he provided us just with the functions to calculate this, and we put it in this component, the date and time selector component, and this is just providing a 3D vector to the 3D scene, and this is then using it as a vector for the directional line. So these components work all together. And here implemented some kind of messaging bus between both components, because we are just putting messaging in the browser. You have to know which of these components which I see needs to communicate with the other components. For example, the list view with the annotations, the buttons, just send a message to the X3D component which says, okay, move there and show this. Or the shadowing component says, okay, this is the direction of the light. And this is just sent as a message to the X3D component, and if something happens in the X3D component, it also posts a message to the outside world, which can be registered and processed. So we are facing some challenges within this project. For example, city models tend to be very large, and we have to do some performance optimization of X3D data to reduce the number of state changes to have some decent performance. We need to consider the hardware in the offices of the city, because most of the time they have very old computers, or even with a very low technology graphics hardware. And we do optimizations using AOPT, which moves objects or so to speak, arranges the whole scene graph to move objects of the same properties in one group and draw it as one, so to speak. And this has some side effect. Semantics of buildings can get lost, for example, and this limits the possibilities for interaction. For example, you cannot discern walls, roofs, ground, and special areas, so it's very hard to find out what was clicked on, for example. You just have to click on faces. So we follow a mixed approach here. We have some more or less background objects, which are the rest of the city, and some interactive objects, which you can work on, which are not so highly optimized, which work quite nicely. And then we presented this to the cities, Bologna, Vienna, and Liferay states in Spain. And the results are mixed. For example, a city like Vienna has a very, very sophisticated 3D model, which was very easy to use and to display in 3D, but on the other hand, Vitoria had no model at all. So we just created a single box model out of footprint data, pedestrian data, and this, and said, okay, we know how many stories are there in this building, so raise it 3 meters times the number of stories. And it had some, it looked quite nicely for the ease it was done, but the people had some difficulties in identifying their own neighborhood. So it's very crucial we have some good data, even to have some landmarks within the 3D model so that people can identify their home. Also, we discovered usability is still a very crucial point for this. The stakeholders for this public participation, especially no IT experts. And we also have to consider different age groups and different kinds of devices. So it should be very easy to access the low barrier to access for data and 3D content. And finally, it has also some issues in integrating the X-Freedom in the Liferay environment. For example, Liferay is a very classical web application with request-response cycles. So this implies that every time you reload the page, the 3D data has also reloaded. And we have also some CSS conflicts with reporting, because it brings in a lot of stuff from different frameworks, and we have always to respect the CSS of reporting and the other JavaScript components. And also, if you're working with this Portlet standard, which is the basis for Liferay, you have a modeling concept on the server side, but not on the client side, which means different components can deliver different parts of JavaScript within the same browser application, which is really hard to isolate from side effects. So I would say that you need to have a completely different portal application infrastructure for this. Performance optimization and semantics of receiving URL for interaction has to be considered. Yeah, I think I mentioned this before. And feedback we got is it's a quite nice application. People can work with it, but on the other hand, the data is for the crucial problem. The cities need to have tools to create compelling 3D models. They need to identify with their own neighborhoods. And there's just one last point I want to put up for discussion. We have some interactions. We have seen some interactions with the 3D scene. For example, moving the objects or putting in some annotations. And we used a lot of JavaScript code and created JSON objects from this and sent it to our server and stored it in a normal database. So every time I'm coming back to the 3D model, I have to create the database for all the things that have been placed and regenerate all this with the JavaScript code. So I don't have a simple one file solution to store all the data in an X3D, for example, which would be very great to archive all this. So maybe there's a possibility to consider this in a standard somehow, to have some interaction and amend all this data. But I'm not sure. Maybe I'm just mistaken here, but it's just a different, so to speak, second state storage source, which has to be considered all the time. There's on the one hand the 3D data, and on the other hand the data which is entered by the users, and both have to be brought together with JavaScript. So it would be nicer to have just a new X3D file which considers both. Okay, so far from me. Any questions?
Questions? Yes. Just curious, how many users can actually use it? You know, it looks like you deployed this to the public because you've got some comments. How many users and how long total they use this?
It's not public yet. The question was how many users are using this right now. It's just in the evaluation phase at the cities. So about 10 users up to now. So they want to put it into the public if they are sure it's working for them. So up to now it's only very limited.
How much time have they spent on those 10 users total?
How much time have the users spent on using the application? What's the question?
Yeah.
Not that much. I would say 2 or 3 months in total. Because it's just a European project which is to be done apart from normal things during the cities, and it's really hard to get them to use the tools we created as a research project.
It looks like a really great project, and is it possible to make some of it available, even if your clients have questions? Is it possible to make some of it available for other people to look at the project?
Of course, it could be, but it's just not clear up to now how we want to make this public. So, for example, we can provide the 3D components, but we to be easy. It's just a thing we have to talk with the European Commission and find out what are the options, because it's founded on them. So,
but the European Commission has a clear dissemination policy, so they want things to be used. So it's quite clear it will. The only question is which of the data is usable to the general public, not the tool per se. The tool per se quite clearly, once the project is done or at the stage where it can be used by the public, the Commission will be thrilled by the fact that others use it as well.
Yeah, but even it's like, even if it was a make-believe city, a city that doesn't even exist, it's a nice example of sort of a...
But you know yourself, make-believe cities are very hard, because you invest a lot of energy for a believable city, and then it's all for void. So here you have real cities, and so I think it's better to play with the real cities. And I don't think the cities have a problem. It's just that the project phases are clearly set up in a way that at a certain point dissemination starts. Before that starts, I think it's a bit hard to get access. This is really the point.
Yeah, thank you guys. If you can't release, I see two things that the X-ray group has been looking at that might benefit from this. One is, how do we configure portals? You know, not typical of city, but just doing an X-ray and plug in. We would be happy to test when you're at that point on our Liferay. Also, Leonard Daly recently upgraded the web3.org site. I think he's using Drupal. I think the NIH Print Exchange is using Drupal. So there are a few open portals out there. We might document how to do it, or checking code to those open source portals so you don't have to reinvent and maybe get it wrong. So the first thing. The second thing is, I've seen it over and over again in many papers. You're being very deliberate about workflow, documenting your workflow. It's really interesting. Nick, are you here? Did you take an action item on that for workflows? Or? I heard Anita use your name in vain the other day.
Often my name is used in vain. No, that is actually a challenge we're issuing to all the working groups, in fact. So it should be the domain experts who are in the CAD or in the Geo that can talk best to the workflows.
Yeah, so it's very interesting how deliberate you've been on your workflow. So when we start comparing these to see what's the same and what's different, I think both of those would be really interesting as we start showing workflows. Did you find workflow helpful? Was it?
yes.
Just a technical question from my side. When you mentioned the scaling doesn't work, of course it doesn't. Because when you bring floors close together, you don't want to shrink the stairs and take some stairs out. So the question is, how difficult is it to bring semantics into the buildings in terms of seen from your architecture, that stairs know about their nature, that ramps know about their nature, that cars have to drive there so they can't shrink them below a certain threshold. Is that difficult, or?
This is exactly what I'm researching on. So I think it must be done. It's huge and enormous. It's a big advantage if you have this information. It's not just the geometry you have, but you have always also the semantics, and you can do more with it. And to integrate it into XVD, we have to experiment somehow with metadata.
Thanks so much. So, are there any more questions? Then let's thank the speaker again.
I can mention Mike's framework from the same group, which was very helpful in writing the paper. Thank you for that. Okay.